Hello everyone, and welcome to this week's edition of our Cassandra Community webinar series. I am really excited today to have with me Christos Kalantzis from Netflix. Christos is the engineering manager of the Cloud Persistence Group at Netflix, and what he's going to talk about today is he comes from a heavily relational database background. In a previous life, he was a DBA, and now he has become a database engineer. So he's going to talk all about that transition. So I'm going to hand over to Christos now, but before I do, I just wanted to remind everyone, if you would like to ask a question of Christos, please use the Q&A tab inside of WebEx. Post your questions there. And at the end of today's session, I will go through those questions, ask Christos, and we will get through as many as we can. So without further ado, I would like to welcome Christos Kalantzis.
Thank you, Christian. Hello, everybody. So, oops.
Yeah, let me put it back on the on that slide for you. So just check you can advance it.
I've got it. Got it. Perfect. So, okay.
You now have presenter
great
capabilities.
Hello, everybody. So, keep the DB, lose DA. Today, we'll be talking about how DBAs can shed the administrator title and become DB engineers. So we're going to cover this topic and everything it entails in 4 steps. First, we'll start with a brief history of databases, the evolution of the technology, and the challenges we faced with every step. You know, a wise man once said, you need to know where you've been to understand where you're going. We'll then look at how this evolution of databases has molded current DBAs and the list of skills they've amassed. Finally, we'll define what a DB engineer is and really dig into the skills that are required to you know, ascend to this next level of expertise. So, let's get started. So, a brief history of databases. In the 60s, you know, while a lot of people were celebrating peace, love, you know, computerized databases, you know, made their debut in the 60s. Since computers were getting, you know, more cost-effective, a lot of private companies were using them more and more and relying on them. 2 popular database models existed in the 60s. One was the network model called Codicil, and there was also the hierarchical model called IMS. A very successful database, hierarchical database system, which existed back in the 60s, called the Sabre system, was used by IBM to help American Airlines with a reservation system. It was really, really early days in the 60s. Then the 70s rolled around. You know, hard rock dominated the airways. You know, there were huge lines to get into Studio 54, but there was a cooler place called IBM, and there Edgar Codd wrote a paper about the relational database model, which, you know, pretty much started the RDBMS revolution. In the 70s, 2 major prototypes were created based on this model. One was Ingress, which eventually begat Ingress. It begat Sybase, which in turn turned into MS SQL Server. There was also System R, was another one of those prototypes, and the modern DB2 and Oracle were really modeled after that prototype. Also in the 70s, Peter Chen, he came up with the entity relational model. I mean, that, it's basically what we use today to focus on designing database applications instead of focusing on, the logical database structure. Now, you'll notice that in the two prototypes I listed, Ingress and System R, they both used different querying language. Ingress used QUEL, System R used SEQUEL, and there was very little interaction. If you knew one, it was very hard to work with the other. Well, that was all fixed in the 80s. So, along with catchy new wave pop songs and androgynous hair and clothing styles, there was also SQL, which made its debut, the structured query language. SQL really became the standard way to query all these database systems, all these relational database systems, which we, still use today. Another thing happened in the 80s as well. I mean, personal computers became popular, became affordable, and with that came really a slew of new database products. Some of them you might know, you might have never heard of, which, quite frankly, makes me feel kind of old. There was Paradox, Whatcom SQL, and my personal favorite, DBAs. Yeah, I miss DBAs. But that was the 80s for you. Then the 90s came around. Grunge replaced pop, and also at this point, databases really, got firmly rooted in companies all over the world. I mean, I think we all remember the three-tier application model: client, server, database, right? All those applications mostly served internal users or limited customer base. They only had to support hundreds, or in the case of really big companies, maybe thousands of users. Well, the internet came along and really changed all that. Towards the end of the 90s, the internet exposed applications to potentially millions of users. And if you were lucky, you cashed out before your database crashed. But seriously, traditional RDBMS systems were being pushed to their limits. I remember in the late 90s, as some of my, in my early DBA career, we spent wads of money to scale up those servers. So we added RAM, faster disks. We chose servers with dual power supplies. We were utilizing redundant disk architectures, different RAID configurations. I mean, we struggled back then. Then the 2000s came along. In the Web 2.0 world, we became the product. Companies started to realize the value of data, both the data they were collecting and especially the value of the data they were not collecting. So the scramble began to collect big, and I mean huge amounts of data. Basically everything that they could store about their millions of users, their behaviors, their likes, their dislikes, and all to, quote unquote, try to serve them better, which for a lot of companies meant, serve them targeted ads. Other companies like Netflix, where I work, we use it to recommend, better movie choices to you. Aren't we nice? Some new techniques to store this massive amount of data on RDBMSs, which were still in the early 2000s was the prevailing database products out there. New techniques were created. Sharding came along. Sharding was good because you continue to use your existing RDBMS solution, to store these massive amounts of data and to be able to query it effectively. But I mean, that added complexity to applications. Now, you know, the location of the logic to store and retrieve certain data was built into the application and higher up into the whole application stack. Also, another thing that happened in the 2000s, disks became really, really cheap. You know, we no longer felt the need to be stingy with our storage. So we started to denormalize our data. You know, the thought being that if we simplify the model, less joins were needed to serve a request. So if there's less joins involved, there's less disk I/O, less data needs to be stored in memory to perform those joins. So you know, we can serve requests much faster. And the trade-off is, you know, you're wasting more space on this because you're duplicating a lot of the data you wouldn't have in a relational model. This is what we call the NoSQL movement that started a few years ago. And new databases such as Apache Cassandra, CouchDB, or Mongo all came along and implemented this NoSQL unstructured concept. As long as you had a key to your record, I mean, you can query the data stored with that key. And this pushed, once again, the responsibility of worrying about what shard is holding your data back down to the persistence layer of the application. Now, I also talked about how companies, you know, saw the value of the data they were collecting and started slicing and dicing this massive amount of data. Well, to be able to do that, new techniques in analyzing data also evolved in the 2000s. You know, technologies like MapReduce that led to products like Hadoop. You know, now the analysis of all this unstructured data from different sources can be spread out amongst hundreds of nodes, allowing companies to use commodity hardware or even in the case of, you know, Netflix, disposable virtualized servers to perform, you know, these offline computations. So unlike in the 90s when we were scaling machines up, you know, in the 2000s we got cheap with our hardware and started using commodity hardware, and the products we were using allowed us to use that because of the availability that was built into these products. Now, so as the databases and the challenges running these database applications evolved over the last few decades, you know, so did the individuals who were responsible to tackle these problems. These individuals, or some might call them warriors, you know, were the DBAs. A good modern DBA had and still has many talents, and probably, you know, some would say worth their weight in gold. If we look at some of the skills DBAs have today, you know, they're still masters of ER modeling and designing schemas in the third normal form. You know, applications today are still being created using frameworks that still expect an RDBMS at the persistence layer. I mean, look at Ruby on Rails, look at Grails, look at the Django. There's still an assumption of an RDBMS in the persistence layer. So DBAs, you know, need to make sure the physical model reflects what the application is expecting, and still provide the SQL to create, modify, and query the data. Even though a lot of these application frameworks can do that for you, my experience is that they're less than ideal, and you still need a good DBA to make sure things are ideal at the physical data model layer. DBAs are also data product experts. They need to know. Either Oracle, SQL Server, DB2, or MySQL, and really understand how the individual database product interprets a query in the underlying query engine of the database product. I mean, this is necessary to help troubleshoot slow queries. An example is, a query you send to Oracle with subselects is not going to run that efficiently on MySQL or maybe SQL Server, and that's why a DBA really needs to know the internal workings of the query engine to help troubleshoot those types of scenarios. Also, they need to know how, what happens if you modify certain system variables of the database product and tune it for performance, because not all applications have the same read-write pattern. So one application might require more query cache, one application might not require either because it's mostly a write application and not that much of a read application. So I mean, DBAs need to understand all the knobs available to them in particular database products. The DBA also needs to be well versed in the OS that's running your database that's running on your database server. And that's very important because DBAs are often responsible for the installation of the database product, troubleshoot issues of I/O performance, find I/O bottlenecks, identify if there's enough RAM on the database server, and if the server's paging. Basically, I mean, they need to also be Windows or Unix and Linux administrators as well. Especially in the 90s, when single server database servers were being pushed and scaled up, were being pushed to their limits, so they were being scaled up. DBAs also became system engineers. In trying to identify potential issues with either I/O or lack of RAM or CPU load. They started being responsible for making hardware choices on those machines. So DBAs learned about the processors on the market. What does it mean to have multiple cores, multiple sockets on a motherboard? How does hyper-threading affect your database performance? They also became responsible for choosing how much RAM that particular database server required, and leave enough space there for growth. Another thing they became responsible for is, and it's personally my least favorite, is measuring the amount of IOPS required to run the application. And decide between either SCSI, SATA, a SAN, whether to go SSD or not in recent years, and what RAID configuration to use. So DBA started dabbling in hardware as well. Finally, a DBA needs to have scripting skills. But there's a lot of mundane, repetitive tasks that require automation, and a DBA needs to script and automate those tasks, or else they'll never get out from under the weeds. So, I mean, it's all pretty impressive, huh? I mean, it's a lot of responsibility that we've put in DBA's hands. Well, it's good, but in today's big data reality, it's unfortunately not enough, or at least it's different. What we need today are DB engineers. So what is that? A DB engineer is more than a DBA, because although all the DBA skills are necessary, there's also some new skills that need to be developed, and we'll cover those skills in a little bit. Also, the DB engineer is not a software engineer, but in a good way. Software engineers usually work on specific problems with known input and an expected output, and need to implement that solution. A DB engineer is different. A DB engineer needs to take a step back, look at the forest from the trees, and understand that his or her decision will greatly affect multiple layers of the application stack. It's even more responsibility than DBAs had before. So what are the skills required to be a DB engineer? Let's start looking at that. We talked earlier about how in this decade the collection of data has grown astronomically. So a DB engineer needs to figure out how to store all that data. And many factors come into that decision. Like we said, new data design concepts were introduced in the 2000s, and a lot of them, all these design concepts need to be understood and mastered by a DB engineer. So, will the decision be to shard your existing RDBMS? Which in one way, won't require new skills at the ops level because they're still managing the same MySQL or DB2 server. But, we've now put the burden, like we discussed earlier, up at the development level. Are you willing to try a new NoSQL design? What does that mean to the dev organization and your existing code? Like we said, there's no more joins. The responsibility for joining will be at the application level. There'll be more seeks for secondary indexes. So, the trade-offs, the advantages and the trade-offs of going NoSQL need to be understood. Another thing is, how will your existing data model translate to a distributed data model? Like I spoke also with the NoSQL, if you've got multiple nodes in a cluster, multiple shards, you can't join between them. You may be able to join between a shard because it's still possibly an ER model, but in a distributed database, you can't join between data that are in different shards. What does that mean to your application? A DB engineer really needs to understand the limitations of a distributed database and its advantages to be able to make the appropriate decision. Next, if you do go down the NoSQL route, DB engineers will then need to implement these new, NoSQL models using one of the new database products out there. I mentioned Apache Cassandra earlier. There's MongoDB, or some people are using HBase. Which one to use really depends on your use case. Cassandra is blazingly fast with writes because all writes are immutable. However, this makes reads a little slower. Some will say MongoDB reads are quicker. However, Mongo locks a whole table while it writes because its writes are not immutable. And it's operationally more complex to run than a Cassandra cluster. So a DB engineer decide the appropriate technology to use based on how the company works at. is it a Java shop? If it's a Java shop, then, you know, Cassandra might be a better choice because it's open source, it's nice, clean Java code, and, you know, it's not difficult to patch it and roll in your own fix. Hopefully you give it back to the community as well. So that's also a factor of which product to use. And a DB engineer really needs to understand the trade-offs between every product. So they'll have to play with these different products and understand them. Also, another factor of which product to use is, are you going to run this on commodity hardware? Are you going to virtualize your database? Here at Netflix, we run Apache Cassandra in the Amazon EC2 cloud, not on physical hardware. However, one of the reasons why we chose Cassandra is because of the flexibility it allows to be able to do that. And plus, it's open source. Netflix is a Java shop. We patched Cassandra to be able to make it more cloud friendly. And that was another reason why we moved that way. Now, because it works for Netflix doesn't necessarily mean it works that decision works for you, but I mean, this is everything a DB engineer needs to weigh in making that decision. Also, DB engineers need to really understand all the layers of the application architecture when deciding, you know, how to store data. You know, the decision, like I said earlier, depending whether you go sharding or a NoSQL solution, really can impact multiple layers of the application. You know, if you choose to shard, like I said, you know, new logic needs to be introduced in the domain or data access layer to identify which shard is holding that information. Otherwise, you know, maybe you'll choose, you know, one of the new auto sharding database products I mentioned earlier that handles that for you. But now, you know, you can't necessarily use you know, the ORM layers you've come to rely on, like Hibernate and so on, out of the box, because, you know, there isn't an RDBMS at the persistence layer anymore. Heck, you might even decide to introduce a service layer for the persistence layer to completely obfuscate the actual data product underneath. And just provide like a CRUD REST API or a CRUD Java API, and at that point, you know, developers don't need. You're completely hiding the complexity of the persistence layer from the developers, and just giving them an API that they can use to store their data. But I mean, going that route, you know, you're introducing another hop. Another layer in your architecture, and you know, most probably increasing latency of you know, calls between different layers of the application. So, I mean, also, you know, there's an issue of consistency as well. A lot of these distributed database systems are eventual consistent systems. I mean, there are some that are tunable, but if you really want to get, you know, the speed out of them that they can provide, you know, one of the trade-offs might be to, you know, set it to be eventually consistent, and you know, that completely blows the mind of developers when you tell them that, hey, you might write something, and if you read it immediately afterwards, you know, you might not get what you're expecting because it hasn't replicated across, the data hasn't replicated across all nodes. So, you know, there's a chance you just might not get your data retrieval might not be consistent. And so you need to help developers and application architects understand that and build mitigating tools into the application stack to handle that. Finally, a DB engineer also needs programming skills beyond just the automation and scripting they perform as DBAs. So we talked a lot about, knowing architecture, recognizing the changes that need to happen in different layers of application. A lot of times, there's going to be resistance to change. I mean, there's always resistance. There's frequently resistance to change. The only way to prove your designs and maybe even your database choice is to implement prototypes of your solution. And to do that, you're going to have to code beyond just scripting and automation. So, I mean, and what language you choose obviously depends on the development culture of the company you work at. If they're a Microsoft shop, it might be .NET, or if it's like Netflix, a Java shop, hey, you better brush up on your Java. There's companies that are Ruby shops, Python shops, Groovy shops. So, I mean, you're going to have to develop prototypes of how the application will communicate with the persistence, with this new persistence layer and this new data schema. Also, I mean, a lot of times prototypes turn into production code. So, your prototype, you prototyping this might lead you to bring up recipes for other developers in your company to model their implementation on. So developing programming skills are very, very important. I mean, remember, as DB engineers, they're big data trailblazers, and other teams, other dev teams, they're really looking at DB engineers to offer the guidance in not only design, but also implementation. So DB engineers are quickly becoming the cornerstone of DevOps shops, of dev shops, and especially of companies that are big data, that have big data focused applications. DBA positions, they're being outsourced. They're being handled remotely, and if you want to stay cutting edge with your skills and really remain highly marketable, then you really need to kick that A from your DB administrator title and be a DB engineer instead. I know at Netflix, I don't hire DBAs anymore. They just simply don't have the skill set I'm looking for. And, DB engineers are where it's at, whether it's in the DevOps or in an application development team. They're becoming really, really important. And, I really do hope DBAs out there, continue to learn and really elevate themselves to DB engineers, because that's the skill set and the people hiring managers like myself are looking to hire today. Thank you, everyone.
Thank you very much indeed, Christos, and good plug there at the end for jobs at Netflix, and I know you're very involved in that. Did you want to tell anyone about the OpenStack event next week, if anyone's in the Bay Area?
Absolutely. So Netflix is doing open source, not OpenStack, an open source open house at our offices at Los Gatos. Christian, can we forward the invite or an email later on with the presentation?
Yeah, absolutely. There will be an email going out tomorrow with the archive of the presentation. We can definitely include a link for that event in that. No problem at all.
Fabulous. So it's February 6th. It's at our offices in Los Gatos. It's after 6:30. We'll be serving food, beer, and doing some, quick fire presentation of our open source projects. For those who want a preview, go to netflix.github.com, and we'll also have demo stations actually showing off this software. So it's going to be tons of fun. If you're interested in open source software and see and really look at a company that's invested highly in open source and in open source their own stack, please come out.
Okay, great. And we'll start to take questions now, so feel free to ask your questions in the Q&A tab in WebEx. So while you're typing those, and I'm getting ready to ask them of Christos, a couple of other things for your calendars. So we have, if you're on the East Coast, we have a very large Cassandra-centric event in March 20th, and that is on the DataStax website. A lot of what Christos talked about today, making this transition, you need some educational materials for. This webinar series is an educational webinar series, so make sure you do not miss the next installments as well. But also, planetcassandra.org, that's the Cassandra community website. That has a lot of resources in it as well, so that you can start to get skilled up in Cassandra and big data. So, Christos, we've got some questions coming in right now. Oh, I'll take Arthur Zubarev. He says, I'd like to see more practical examples of Cassandra uses, implementations, and developer experiences. There is a users page on Planet Cassandra which has some use cases on there. We are adding more and more. And as the next phase of the College Credit webinar series, we're actually going to be featuring use cases from different companies front and center. So thank you for that feedback.
Also, Arthur, if you are in the Bay Area, like I mentioned, come by the open house on February 6th at Netflix, and we'll be definitely showing off how we use Cassandra. Oh, you're in Ontario. Okay, that's unfortunate. But for anyone who would like to see use cases, please come out. I mean, we're going to be showing off not just how we use Cassandra, but Priam and Astyanax, which are our open source. One is a sidecar to Cassandra, and the other is our Java client library, and showing off how developers use it.
So thank you very much for that. Arthur, ping me, Christian@datastax.com. I will get you a discount code for the New York event. We are featuring a lot of use cases at that event, from Comcast, from eBay, and Blue Mountain, several others there, some great use cases. Christos, I'm going to take this one from Asim Dayal. We are an Oracle shop and are very used to SQL and ad hoc queries. Are there similar tools for Cassandra to query the database? So yes, there is a tool called CQL, Cassandra Query Language, that is very SQL-like and allows you to easily query the database. If you are familiar with Oracle, you know of a tool called Toad, and there is actually a Toad for cloud databases. That's a free tool available from Quest Software, now Dell, which allows you to use standard SQL to call Cassandra and a bunch of other databases as well. HBase, Hive, bunch of others. So check that out. Okay, so are you ready, Christos?
I'd like to take Arthur's question.
Yes.
Is it possible to use Cassandra without involving Java? Well, yes and no. So let me explain, Arthur. Cassandra is a Java application, after all. So the server itself need Java. However, clients don't actually need Java. I believe there's client libraries for C#, for C, for definitely for Python. So there's definitely client libraries for languages other than Java.
All of those client drivers are available on Planet Cassandra as well for free download. Those are community drivers, so check those out. Okay, so Christos, when setting up a new production Cassandra cluster in AWS, what are the most common failures or config issues you could run into, and how did you mitigate those? You know, that may be a question for Jason or one of the other team, but wanted to put it on your radar.
Sure. I'm going to answer this very high level. You know, a more detailed answer can take a very long time and probably requires one of my developers to dive that deep. But mainly, the main challenge with running Cassandra in AWS is limited I/O. So if you're running a non-SSD EC2 instance, you know, there's very limited I/O available to you. It's actually there's a, you know, it's topped off at maybe it's either 100 or 1,000 IOPS, and so one of the major challenges, I wouldn't call it failures, but one of the major challenges in configuring a Cassandra cluster, a production Cassandra cluster in AWS, is sizing. So, you know, if I was running my own hardware, then, you know, space on disk is really the mitigating factor for how many nodes I'm gonna need. Whereas when you're in the cloud, you also have to you're possibly gonna have many nodes that have very little data because you want to get to that ratio of 1-to-1 with memory and data within every node of your Cassandra cluster. So that's one of the major challenges of running Cassandra or any database system in a virtualized environment. I hope that helps, Jim.
Thanks, Christos. And follow-up from Jim, do you or are you planning on utilizing DataStax Enterprise Cassandra that includes the Solr and Hadoop integration? So yes or no? If no, why not? And I know you and I have talked about, you know, some projects internally. Do you mind addressing that one, Christos?
Sure. We are. We're moving towards DataStax Enterprise, especially for some applications that require what is coming in version 3.0, you know, enhanced security. Netflix is a public company. You know, we're subject to SOX compliance, PCI compliance. So, you know, we need the extra security layer that DataStax Enterprise 3.0 is moving toward. And plus, you know, Cassandra has gotten more stable now, a lot more within the past year. So we don't feel the need to patch the community version regularly. So now we can, you know, upgrade slower and kind of offset that responsibility of packaging Cassandra to DataStax and really take and really just get a packaged product from a vendor as opposed to having to do it ourselves. Now, as for the Hadoop or Solr integration, Solr is very interesting to us. You know, as anyone who's played with Cassandra knows, you know, querying on secondary indexes, although with CQL is easier, still has a performance impact. And we're hoping, we're starting to dabble with Solr, and we're hoping that the Solr integration will now allow teams that want to do more ad hoc querying on production data a lot easier.
Thanks, Christos. And you touched a little bit on security. Prasanna Joshi asks, would like to know the security features in Cassandra, authentication, authorization, encryption, of data on disk and data in transit. Do you feel comfortable addressing those, Christos? If not, I can touch a little bit.
Sure. So data in transit, there's a lot of data in transit actually in Cassandra. There's data going between nodes. There's data going between data centers, and that can be encrypted using SSL. And there's also the data between an application and the cluster itself. I don't remember which version introduces this, but I do believe more recent have implemented SSL from the client to the server.
Yeah, it's 1.2, Christos.
2, okay. However, I'm not too sure about internode communication, whether that's open or not. So maybe Christian, you or somebody there can rush you that answer.
No, you've covered it pretty well in you know, the Apache Cassandra, you know, open source version. It will continue to add security measures, but in DataStax Enterprise 3.0 that will be available on, I'm on the spot now, February 25th, we're launching. We're in the early access program right now. It has advanced security measures. That's the big so what of that release. So if you are interested in that, please you know, ping me and I can connect you with our VP of products. Jim asks, and I'm very familiar with this one, Jim, VP of Engineering at Dig was let go. The scapegoat was Cassandra, which caused uptime issues on their last big release. You know, Christos, I'm going to point this one right at you. Do you feel Cassandra is in a better place for enterprise workloads where stability and uptime is key?
Absolutely. So the key to what you wrote there, Jim, is years ago. So Cassandra has evolved tremendously. You know, not just within the last couple of years, but even within the last couple of months, the last 6 to 8 months. Netflix stores all its data in Cassandra in the cloud. I'm emphasizing all. Except for financial stuff for SOX compliance, everything, metadata about movies, our customer information, our you know, our recommendation algorithm, the results of our recommendation algorithms, all that's stored in Cassandra, in the cloud. We trust it completely. We're a multi-billion-dollar business built on top of this. You know, I don't know how much more I can convince people. It's working. And if you look at some outages, some Amazon outages we've had just, you know, within the past 12 months, none of them were about Cassandra. Cassandra hummed along, you know, perfectly, happily. If you know anything about the Netflix application architecture and the strides we go to keep things up, please do read on our tech blog about Chaos Monkey and Chaos Gorilla. We purposely kill nodes on purpose to make sure that the availability model of Cassandra is proven. And we aim those Chaos Monkeys and those Chaos Gorillas at Cassandra as well. So definitely, we trust it 100%.
And Scott asks a follow-up question. Does that include the actual movie content? Is that stored in Cassandra?
No, it's not actually. So that's a very good question. No, just the metadata. We store our masters in S3, but I mean, movies are at CDNs, really close to the edge of the network. No, we don't store the movies in Cassandra.
Asim Dayal asks, by the way, we're getting through a lot of questions. This is great. Are there no DBA type activities needed for Cassandra? data locks, scheduled jobs, patches, upgrades, data backups?
Yes. Okay. Great. Let's go through this. Well, let me answer this with a broad stroke. We don't have DBAs in our Cassandra teams. I have DB engineers who are former DBAs who understand, and I've got a DevOps team as well that manages upgrades and so on. But there are no DBAs in the traditional sense. So what do I mean by that? Part of why I've got no DBAs is also tightly linked to Netflix's development culture of freedom and responsibility. We try and not have operations and DBA personnel. We have DevOps. We give a lot of responsibility to our developers as well, and who some of them I would call DB engineers. It is handled by developers and it is handled by the DevOps people. So I don't have traditional DBAs. What I've got are people who are DevOps and automate or script out the upgrade process.
Okay, Christos, Francisco, you talked about Chaos Monkey. Is the tool that does Chaos Monkey open source? Can someone else pick up what you're doing and sort of replicate those same failure tests?
I'm sorry, can you repeat the question?
So your Chaos Monkey tests, is that open source? Can someone pick that up and sort of replicate what you're doing?
Absolutely. So if you go to netflix.github.com, you'll see something called Simian Army, and Chaos Monkey is part of that. And it's not just for Cassandra; it's for killing nodes in all levels of your physical application deployment. So yes, it's open source, and if you're in the Bay Area, we're going to be showing demos of it on February 6th at the Netflix Open Source Open House.
Awesome, thank you. Sanjay asks, using Cassandra as a cache, are there any use cases on this at Netflix? And before you answer, I'd just like to, we actually have a new success story on Datastax.com, which is Adobe's marketing cloud, and they use Cassandra as their what's called their edge cache. So there's some information there. Christos, over to you.
Yeah, you could definitely, and there are some teams that are using it that way here at Netflix. But remember, the whole point of a cache is to increase read responses. So you really want to make sure you're getting as close as possible or at that 1-to-1 ratio of data and memory. The initial as you load that cache and it reads from disk and then it stays in system memory, you'll get great response times, and using Cassandra as a cache also adds the added benefit of the values in the cache are actually persisted to disk in case of failure, as opposed to like EV cache, and memcache, which if you lose the cache box, it's all in memory. You lost all your data.
Okay, I think I'm just doing a quick scan, and we're just 5 minutes from the top of the hour. Yeah, we got through a lot of questions, Christos. Thank you very much indeed. A couple of people were asking for your Twitter handle and contact information. So I have put the About the Presenter slide back up there. At Chris Kalantzis, follow him on Twitter. I am at Chaska on Twitter, and we try our best to be responsive to the community and get questions answered. So thank you everyone very much for joining us today. We really appreciate it. We will see you if you have your calendars marked for Valentine's Day. We'll do a little bit of a deep dive into one of the new features around Cassandra 1.2, which is called vNodes. So the title is V is not for Valentine's Day, it's for vNodes. Patrick McFadden, great speaker, will be presenting on that. We hope we see you there. Thank you very much.